Okay, so it looks like we are live, I think. Oh, I think we're live is what this is indicating to me. Oh, yes, I want you to be that big. You, I want to be smaller. Good, that's fine. There it is. What is going on here? Okay, come on. I don't know. Okay. Yeah, looks like we're good there. Why are you sitting here? Okay, good. Okay, excellent. Now I need to mute this so that we don't get a bunch of crosstalk. And there we are. Okay, now I'm going to need to turn this off, their test pattern, so I can size these windows properly and hope that they're in the right place. It's been so long since I've done one of these. And of course, this usually happens anyway. I resize my windows and then I gotta resize them again when I do my next live stream. Okay, well, we're pretty close, not too far off. I gotta go up a little and over a little. Probably up a little more than that. But we'll have to see how that goes. That's probably close enough for the moment. But good evening, everyone. While we're waiting for that to refresh, my name is Mike Jerry. Welcome to the Death Valley region of California. Well, it was a beautiful day today, about 70 degrees or so today, and had a really nice day. And tonight is quite a beautiful night. So, looking forward to doing some pretty nice stuff. We're going to do the January Observers Challenge tonight, which let's see, where do I want to be here? Yeah, the January Observers Challenge, because we didn't get to do it last month, so we're going to do it this month. And so here's this stuff, and got a mixture of galaxies, planetaries, bright and dark nebula, and some globs, which are always nice. So we can start off with some globs, actually. Globs are pretty nice things. M79. Actually, I've started with this one here, which is the Intergalactic Wanderer, Caldwell 25, or NGC 2419, just because it was in the area of my star that I used to focus with, so that's where we went for that. Now, let's see where M79 is. Okay, it's well south of Orion, which would put us on the east side, which we already are at. So that wouldn't be too bad to go over there. But this is a nice little star cluster. Let me readjust histogram again, because we appear to have clipped our blacks again. But it's a pretty nice little star cluster in here. Sort of the bottom star of a little set of 3 stars here. But it's a pretty nice little little star cluster. And it looks like the internet connection is going in and out. Comes and goes. But it's a nice little star cluster in here. Hopefully this will come back here soon. Looks like the broadcast is hourglassing. My internet seems to be going up and down this evening. Well, not much I can do about it. We'll forge ahead. The Intergalactic Wanderer, which is it's in itself a globular cluster. Let me check and make sure. No, not you. Where am I going? I need this. Excellent connection. Not receiving enough. Well, I'm not sure why that is, because, now we're back to excellent connection again. Alright, you seem to have hung up. Let's restart you. Alright, well, anyway, Intergalactic Wanderer, Caldwell 25. It's a neat little globular cluster. Excellent connection. We're all good there. I'm not sure why my second computer is continually hourglassing and not reloading the live stream, but I guess I will just have to wing it. Okay. C25 Intergalactic Wanderer. Okay, let's get next target 533. Filter, no. No PhD, no. Okay, again, I need to go. Why am I not getting a run box here? Why can I only run recent? I need to run other things. Why is this grayed out? What am I missing? The only way I'm going to be able to find this is to edit it. That's annoying. I'll only have to do it once. Okay, so this is going to be next target 533. And run. Okay. Now we go to the next target. Alright, and the mount will whiz over there. Where it's pointing right over my head. So hold on, I'm going to go put my the light shield on. Okay, so that should help keep the light out of there. Alright, well, you can see it's a beauty right there. We'll do a plate solve just to center it, but it looks like we're good. Okay, the AM5 brings it right in there. Alright, and then start imaging 533. Next target, next target, next target was... Why do I not have start imaging in here? Start imaging 533. Okay. seconds or 60 seconds on this. So I think 15 will probably be about good enough. Globular clusters are very bright. Do a color balance on that. There we are. Now let's see what Wikipedia has to say about M79. Messier 79. Globular cluster in Lepus, I'm not sure how you do that. Discovered by Pierre Marchand in 1780. It's about 42,000 light years away from us and 60,000 light years from the galactic center. Let's zoom in on that a little bit more. Pull in some more subs. Like Messier 54, the other extragalactic globular cluster on Messier's list is believed to not be native to the Milky Way galaxy at all, but instead to the putative Canis Major dwarf galaxy, which is currently experiencing a very close encounter with our galaxy. This is, however, a contentious subject, as astronomers are still debating the nature of the Canis Major dwarf galaxy itself. The cluster is being disrupted by the galactic tide, trailing a long tidal tail. Zoom in a bit more. I don't want to zoom in too much because then it just looks crappy, but you can definitely zoom in some more. Lots of stars. Doesn't say anything about how many stars are in it, but 42,000 light years away. Now, there are various theories about the globular clusters. One of them is that globular clusters are actually captured galaxies that came into contact with the Milky Way and now orbit the Milky Way and have had a lot of their outer stars stripped off, and the only thing that's left is their cores, which are these dense and intense clusters of stars that exist. We call them globular clusters. So this one was M79. Let's see what else he had in here. M41. We'll do M41 too in a sec. Since it's Canis Major, it's right in the neighborhood. We'll do it here in a second. Now, Now, let's see what happens. Start imaging and then next target. Okay. Glad we got both of you to finally play here. Alright, let's go to M41, which should be very close by. In fact, it should just be another symbol like this, which should be right in this region. Whoa! What the heck? Right in this region here. I don't see another one. Alright, that's M41. Oh, it doesn't have a glob. Oh, it's an OC. Right, it's not going to have. I was looking for this little yellow cross symbol here, which is a globular cluster. This is actually an open cluster. So this is the little beehive cluster. So let's go over and see the little beehive cluster. Oh yeah, this one's going to be much bigger. Much bigger object. A mucho bigger object. And again, we're not going to want to have, no, we'll do 15. Again, we're not going to want to have too much in the way of time. 15 seconds will be more than enough. Yeah, it's a nice big bright cluster. This looks like a great binocular target. It's nice and large in size, and probably would look spectacular in binoculars. This thing's going to be dithering very frequently. Let's see what Wikipedia has to say about Messier 41. Open cluster in the constellation Canis Major, sometimes referred to as the Little Beehive Cluster. It was discovered by Giovanni Battista Hodierna before 1654 and was perhaps known to Aristotle about 325 BC. It lies about 4 degrees almost exactly south of Sirius, with which it forms a roughly equilateral triangle with New Canis Majoris to the west. All three figure in the same field in binoculars. So, to the south, exactly to the south of Sirius, yeah. Oh, I think this is what it's referred to as an equilateral triangle with these three right here. And of course this is Canis Major, which is Orion's hunting dog. So there's Orion up there. And let's get you back on your target. Yeah, okay, and so Orion's there and his hunting dog is here. And Sirius is a very bright star just to the bottom of Orion. And it's actually Sirius is the second brightest star we can see in our skies. The only one that's brighter is our own sun. So in terms of nighttime, nothing brighter than Sirius, which I think has probably a negative magnitude. And Stellarium, of course, won't let me select it. Come on, let me select it. Sirius. Yeah, it's -1, almost -1.5. The sun is -26, so it's definitely pretty bright. Great star to focus your telescope on, or all that sort of stuff. The cluster covers an area about the size of the full moon. It contains about 100 stars, including several red giants, the brightest of which has spectral type K3, apparent magnitude 6.3, and is near the center, and some white dwarfs. It's probably that one there. That one there looks like it's got a little bit of a reddish hue. Hard to tell. Got colors pretty well balanced, but it's one of these two, but this one looks redder to me. Whoop. Wrong screen. Okay. The cluster is estimated to be moving away from us at 23.3 kilometers per second. The diameter of the cluster is 25 to 26 light years and is estimated to be 190 million years old. And its properties and dynamics suggest a total life expectancy of 500 million years for this cluster before it will have disintegrated. And it's definitely a pretty cluster. That will shine really nice in a pair of binoculars. So if you go out with some binoculars and look under Canis Major, which is under... Whoa! What the heck was that? I didn't want to go out that far. So you got Orion up here, and then Canis Major with a very bright star, and then right below that is M41. Pretty low in my sky right now, so if you're living in a more northern latitude than about 30 degrees, I'm sorry, more than about 40 degrees or so, it might be a little bit too low for you right now. In fact, if you got buildings or trees to the south of you, it might be too low anyway. Okay, cool. So that's M41. I think we'll skip the double star. Caster. Well, it's in the neighborhood. What the heck? It's not too far away. See, it's right here. It's Castor and Pollux. And once again, Stellarium won't select what I'm trying to click on. So there's Castor. No, not you. No, not you. And you can see there is a little companion star here. Now, I do not have a scope that typically, so we'll say goodbye to M41, beautiful little cluster. I don't have a scope that has the focal length and sharpness to typically be able to split double stars, unless they have a fairly good distance between them. This one actually looks like maybe it might have enough distance. It's not too snug. Yeah, actually we can see it right there. It's not actually too snug. Let's go ahead and plate solve and sync, because I am off a little bit. But you can see it's not too snug. It's right there. Doink. There we are. In fact, we don't even need to live stack on this. You can see the star right there. Although, I mean, how far in do you go? Is this... I'm not sure which one is the companion. We definitely see a star there. We see a little star there. But see, my scope is designed for faint fuzzy. It's designed for light collection at the expense of sharpness. So splitting doubles is something that refractors do really well, but my little Newtonian doesn't really necessarily do that so well. So unless it's, you know, one of these guys here, we just can't see it. But anyway, there you go with that. Lowers Nebula in Orion. Sharpless 261. Okay, excuse me. Let's since we're on this, okay, 261. 261. All right. Well, we don't even have to. We didn't start live stacking, so I can just go to it. Yeah. Lowers Nebula. All right. Make sure we're on it. Actually, I think yeah, we're basically on it. Okay, so let's start capture here. Start imaging. And now we've got a nice faint object, so we'll be able to leave it at 60 seconds and collect some light. Collect some light. Let's make sure we've got... Oh yeah, and while we're doing this, while I'm in this, let's turn on some background music. Okay. Let's see what we're getting for our first... let's see how the guiding is doing. Guiding is definitely up. Oh, I know part of the reason for that. I'm at too long an exposure. That's why. I need my guide pulses to be quicker than that. Okay. Let's do this. Stretch this out. Bring that over. Color balance a wee bit. Yeah, you can definitely see it in there. Let's let this collect some subs and probably bring some of that nebulosity forward. Darken that background and Hey Frank, good to see you. Let me know if you can hear me okay. I'm getting a lot of hourglassing at my end on the stream for some reason. Let me know if you can hear me okay. Looks like there's a heck of a delay too. Not sure. Good, good, nice and clear. Okay. And are you getting a lot of hourglassing of the stream itself? Or is it coming through okay? It may just be my second computer here that's hourglassing a lot. And hopefully that's all it is, and what you're seeing is okay. Because for some reason it's just hourglassing a whole ton. And it looks like the stream is indicating good connection, so I'll just have to trust that it's doing good. So this is Sharpless 2261. So this object here lowers nebula. And interesting object. Probably with my narrowband filters it would pop out a bit more, but hopefully we'll be able to get some good stuff out of it. Okay, good, I'm glad. So it's just my second computer. For some reason my second computer is struggling quite a lot to see the stream, so I'm not going to be able to necessarily see what you guys are seeing, but I'll do my best to keep the thing stretched a good amount so that you guys can see what I'm seeing here, which typically means I have to stretch the heck out of what I'm seeing so it looks crappy on my end for it to look decent on yours. But so lowers nebula, and this is located right here, right in the arm, kind of like right in the joint of the arm of Orion. I don't know that I've ever really oh, it's a hydrogen beta region. That's interesting. I need to add this to my emission nebula list. Edit list. Add object. Lowers nebula. Very good. Save and close. I'll have to look at that on my narrowband night. Let's go back to that. So we're seeing the good stuff. But yeah, this is an interesting one. Another fun target for my narrowband stuff. Very interesting. I've got a good connection to my internet, but for some reason I cannot. My second machine is just really struggling to pick up the stream. It's just constantly hourglassing. Well, hopefully the chat will work well and I can chat with any of you folks that come along. But the stream itself, the image is just not good. For whatever reason, it's just not good. Let's see how the guiding is doing. That's better. That's much better. 0.7 and dropping, that's where I want it to be. Not 1 point something. For a narrowband filter, I'm using the Antlia ALPT, which is a 5 nanometer dual band. It's the one you've probably read Jim Thompson's report on cloudy nights. where he reviewed it along with the Extreme and the Triad, one of the high-end triads, and really liked what it did. And so I went out and bought one after I read that, and I really like it a lot. I actually compared it to side by side with an Extreme. On one night, I actually shot 2 or 3 objects with the Extreme, then 2 or 3 with the Antlia, and found that they were absolutely identical, except for the fact that the Antlia has no halos around bright stars. So around these bright stars, you would actually see a halo with that filter. And hi Pimal, nice to see you. Glad you were actually able to make it yourself. Hopefully a student or 2 of yours will be able to make it as well. I haven't been doing these very much anymore, just because of, well, I've actually been doing broadcasts, but I just haven't been doing on YouTube. I've been doing it on Night Skies Network, which I'm actually liking a lot better than doing them on YouTube for multitudes of reasons. But there's one major drawback, which is that when you don't get a recording. When you broadcast on NSN, you do not get a recording. So that's the one thing that is bad about, or well, not even bad. It's just one con of doing it that way. But other than that, I like as a broadcaster and whatnot. It's I like broadcasting on NSN much more than I do here, and so I probably am not going to be doing a whole lot of more live streams on YouTube. It's kind of a pain to use. There's more overhead involved. It's kind of annoying. A student told me that she would attend. Please say hi, you are my student, so I can chat about the observations with you. Right. Good, well, hopefully they will. Yeah. So this is Lowers Nebula, and which is in the Sharpless catalog. I don't know if I have any more information on it. I probably don't. I can see if Wikipedia has something. I'll be surprised, but who knows? Lowers. No, there's nothing. I didn't think there would be. I didn't think there would be. And I've added it now, just added it to my narrowband list, so I when I do some narrowband work again, I will be sure to look that one up, because that's a good one. Okay, well there's 10 minutes on Lowers Nebula. Not real strong, not real bright. It really requires some narrowband filter work to bring that out more and knock the star field back a bit. But it looks pretty, and there's a lot of potential there, so I'm definitely going to come back and do that one at some point. Okay, let's go to the next object. That was a pretty one. Where is our next object? Okay. The Seagull, IC 2177. No, that's the wrong one. There's more than one Seagull nebula, believe it or not. This one is in the southern hemisphere, and that ain't gonna do it. So we're gonna need to look it up by the number. IC 2177. There we go. Back to the northern hemisphere. Okay, and I already reset you. Good, let's go. Let's hope we're not in a roof here. Good, we're not. Still plenty high. Excellent. Okay. Let's see what we can pull out of the Seagull Nebula. Okay, well, we're Seagull Nebula. Let's see if Wikipedia has an IC2177. It's a region of nebulosity that lies along the border between Monoceros and Canis Major. I guess I can show you kind of where that is. So it's right here. So Monoceros? I'm not sure how to pronounce that. But there's Canis Major and there's Orion up here. So it's kind of right between Monoceros and Canis Major. In an area that's actually good. Well, it's because this is the band of the Milky Way right here. We're looking out toward the one of the outer arms of the Milky Way here. And so there's a lot of stuff in here, a lot of star clusters and things. And so this is the Seagull here that we're going to be looking at. So basically we're not going to be able to see a whole lot of it because of the size of it. We'll be able to see the head here and not a lot more. But definitely see some of it. Yeah, see, so this is what we're seeing here, right there. So, and we'll do another part of it too. We'll do a few minutes on the head, and then we'll do a few minutes elsewhere. The nebula was discovered by Welsh amateur astronomer Isaac Roberts, and was described by him as pretty bright, extremely large, irregularly round, very diffuse. The name Seagull Nebula is sometimes applied by amateur astronomers to this emission region, although it more properly includes the neighboring regions of star clusters, dust clouds, and reflection nebulae. This latter region includes the open clusters NGC 2335 and NGC 2343. NGC 2327 is located in IC 2177. It's also known as the Seagull's Head due to its larger presence in the Seagull Nebula. Yeah, so this is kind of what we're getting here. But you can see that because we're in the band of the Milky Way, this thing is just this is just there's loads of stars in here. Just a very rich, dense star field as we're shooting. If I back off here, you can see this band, this bright band here in Stellarium indicates where the band of the Milky Way going right through. It goes right by Orion. And so we're looking right into one of the outer arms of the Milky Way. So we see a lot of stars, but this is the head of the Seagull. It's just too big an object for my little sensor to get. As you can see, this red square is basically what my sensor sees, and it's quite a bit larger than what I see. So there's the head, and these are the wings. Well, welcome students, astronomy students, to the live stream. Hopefully you guys are seeing some decent pictures here. My computer at my end, where I'm actually trying to monitor the live stream, is having all kinds of difficulty seeing it for some reason, but hopefully you guys are seeing good stuff at that end. So I don't know if any of you guys use Stellarium, but in Stellarium it's the Seagull Nebula, which actually is one of 2 Seagull nebulas. There's one in the southern hemisphere too, so you got to be careful which one you get. But it's an IC 2177, or it's also in the Sharpless catalog, 2-292, and it's a reflection nebula. That's between Canis Major, Orion's hunting dog, and Monoceros, the constellation here, which I think is a bull. Okay, are we ignoring frames here? No, that's not ignored. Those are from the dithering. That's from the dithering, that's all. Wow, see, now I can't see the stupid stream at all. Interesting. It's claiming, YouTube is claiming that I am not even on the internet, even though on another tab in the same browser I'm clearly on the internet. So it looks like YouTube is having all kinds of problems, at my end at least. I'm not sure why, but hopefully you guys are... yeah, this says excellent connection. So, oh good, you use Stellarium. Okay, excellent. Glad to hear that. Well then, I like Stellarium a lot. It's a very, well, it was designed to be an educational tool, as an educational planetarium. And you can see I've got a lot of lines in here. This here is my horizon line. So right now we're looking south-southeast. This here is the meridian, which is straight up. So when you use an equatorial mount like I do, when you get to the meridian, the mount has to swap to the other side to continue tracking the object across the sky. So for those of us who use equatorial mounts, the meridian is an important line to know about if you're getting close to it. But these are all right ascension and declination lines in here. And that is also how an equatorial mount tracks across the sky. Probably more information than you want to know, but Stellarium is really a great program. Aside from it being a nice planetarium and a good learning tool, you can also drive a telescope with it. So if your telescope has GO2 and is computer controlled, you can actually use Stellarium. You can click on an object, tell it go, and it will actually move the telescope to the object for you. So it has 2 uses for me, in that it drives my telescope as well as helps me identify objects, and even to some degree gives you a lot of information about the objects up here, which is customizable. You can have more or less information if you want up here, but it tells you all kinds of stuff about what it is. In this case, it tells us that the Seagull Nebula is a reflection nebula, which means it is reflecting starlight of the stars that are in or around it. There are also emission nebulas, which stars actually ionize the gases and make them glow of their own accord. They are actually light emitting. The gas becomes light emitting of its own, and that's an emission nebula. And there are dark nebulas as well, and planetary nebulas, which are a totally different thing, but we'll be looking at those in a little bit, actually. Why is this computer claiming that I'm not on the internet? Well, I may have to toggle back and forth to the chat here. I can't, this, for some reason, YouTube is not behaving with my second computer. So this is the Seagull's head that we've got here. So we'll zoom back in on. So this is the whole Seagull Nebula with the head here that we are looking at right here, and this is the wings here. The red box represents what I can see with my sensor, so that's my field of view. So unfortunately, it's too big an object for me to see entirely, but I can get parts of it. In fact, what I may do is just move down a little bit, move the head up here, and just move down a little bit. In fact, I think that's what I'll do anyway. No, let's go. Let's just move it down a little bit, or I should say up. So here, let's go in here and do it. So here's where I can go into Stellarium. Let's pick that star. I hit the space bar and it recenters my field of view. So that's too far south. We're clipping too much of the head off. I'd like to get a little bit higher than that, so let's try this star. That's probably about right. So if I re-slew my telescope to that star, I should be able to get the head and a good portion of the main part of the body. So let's do that. So I've already got this set correct. So now I can just in Stellarium, I hit Control 1, and it moves the scope to that spot, which has already moved. So we'll now start imaging and see if we can't get both the head and the body in this next series. Does Wikipedia say anything else about it? No, not really. Just says it's a reflection nebula. Try. Reloading the thing here. See if that makes. Aha, well, good, David. I'm glad you got over there to see it. It is another great target. Oh, looks, you're getting quite a few students on tonight. Excellent. Good. All right, so we moved, and so now we're catching the head up here, and a good chunk of the body going across here. Again, this object is the Seagull Nebula, or IC2177. If you look at it in Stellarium, well, let's see, am I going to be able to, yeah, there we go. So in Stellarium, IC2177, Sharpless 2-292, so it's in a number of catalogs. And it is identified as a reflection nebula. So that means the majority of its light is coming from starlight that's being reflected by stars either inside it or close to it. This entire area, the entire area of Orion, the whole area in here is, it's actually called the Orion Molecular Complex. There's a lot of interstellar gases in there and a lot of star-forming regions, including the Orion Nebula. And since we're so close to it, we can go take a look at it. actually show you a few different kinds of nebulae tonight. We'll be looking at planetary nebulae also a little bit later on. And yes, this is it is a pretty good binocular target in terms of its size. It might be a little bit faint. We were just on M41, which is an open star cluster, and that's a beautiful binocular target because it's large, and it's all stars, so it's very bright and easy to see. This one would be much more challenging in binoculars to actually see any of the nebulosity. It would be pretty faint. Cameras provide a lot more sensitivity than the human eye can, so they'll pick up a lot more detail. I think I read somewhere that it's the human eye is basically has an exposure length of about 1/10 of a second. So our eyes basically open and close the shutter 10 times a second. And so that doesn't allow for a whole lot of light collection for really faint objects, which is why our night vision and our low light vision is not very good as compared to other species. But that's why we developed cameras, which can leave shutters open for long periods of time. In this case, I'm taking 60-second exposures and stacking each one. So it takes a 60-second exposure, and then takes a second 60-second exposure, and then the software I'm using called SharpCap, it aligns the two images using the background stars, and then lays one on top of the other, and basically adds them together. And as it continues to take sub-exposures, it just continues to add and add and add, and dark places get darker and light places get lighter, and so you get more contrast and can pick out more and more details as you go through the process. And so cameras really open astronomy up to a whole new light. But pardon the pun. I really want to use filters on this, but being a reflection nebula, filters don't help a whole lot. They help a little bit, but not a whole lot, because reflection nebulas are basically reflecting starlight, and stars are full spectrum objects. They shine light in the full spectrum of light. So anytime you filter out something, you're filtering out the light from the reflection nebula as well. So emission nebulas, on the other hand, are a totally different thing. And we'll just do another minute or two on this, and then we'll go to something that's a little bit more interesting, even if we are going off the observer's challenge. Since we're in the area of Orion, we might as well go to the big, bright, shiny stuff. And we'll let this sub finish, and then we'll go over and we'll go see some emission nebulae next. And then we'll go look at a stellar nursery called the Orion Nebula. Alright, the Seagull's head and body. Wish my second computer was working a little better so I could see for sure what you guys are seeing, but hopefully you can see that standing out now. In a very rich field of stars. Okay. Let's go to Alnitak. Lump star, that's even better. Yeah, that should be about right. So now we're going to see a couple of pretty well-known nebulae. And they're both emission nebulae. One is called the Flame Nebula and one is called the Horsehead. And if I have done my positioning correctly, they should both show up in this one view. I have to keep bugging back. Okay, good. Good. I'm glad you guys can see it. See it well. I feel like I'm kind of running blind here a little bit without my second computer. Alright, we should have our first sub coming in here. Yeah, there we go. I'm a little bit low, but that'll work. So this is a really pretty area to view. And in fact, because it's low, I can zoom in a bit more. So this is the star Alnitak. If you look at Orion and the three stars in Orion's belt, it's the leftmost star in Orion's belt is Alnitak. And that is this bright blinding star here. And I was talking about the Orion molecular cloud earlier. This is just another area of, gaseousness around Orion. And so the Flame Nebula is here. You can see this nice tannish color. And then the Horsehead, which you can see right here, the Horsehead Nebula. And these are both emission nebulae. And I'll read here what Wikipedia has to say about the Flame Nebula. The Flame Nebula, designated as NGC 2024 and Sharpless 2-277, is an emission nebula in Orion. It's about 900 to 1500 light years away. So that's pretty close to us, actually. Not too far at all. The bright star Alnitak, the easternmost star in the belt of Orion, shines energetic ultraviolet light into the flame, and that knocks electrons away from the great clouds of hydrogen gas that reside there. Much of the glow results when the electrons and ionized hydrogen recombine. Additional dark gas and dust lies in front of the bright part of that nebula, and this is what causes the dark network that appears in the center of the glowing gas, which is kind of what makes it look like a flame. All that dark stuff in front of it here. It kind of makes it look like makes it look flamey. Okay, the Flame Nebula is part of the Orion Molecular Cloud Complex, which I was mentioning before, which is a huge star-forming region that includes the famous Horsehead Nebula. At the center of the flame is a cluster of newly formed stars, 86% of which have circumstellar disks. Observations by the Chandra X-ray Observatory show several hundred young stars out of an estimated population of 800. X-ray and infrared images indicate the youngest stars are concentrated near the center of the cluster. So, the whole Orion neighborhood is rich with star formation. Where's my mouse here? Back you off a little bit, because actually there is more to the Horsehead that keeps going up. This is another good object to do with narrowband filters. Emission nebulae really respond well to narrowband filters, which help knock down all the stars and the brightness of the Alnitak and the lump star here, and really allow the nebulosity to pop out. But even doing it broadband, it looks pretty spectacular. Due to the brightness of Alnitak, it's hard to see these things through a telescope. Oh, and we're getting photobombed by a satellite. The southern sky is very rich with satellites, so but this whole area is just, the whole Orion area has got a lot of stuff in it. A lot of pretty spectacular stuff. The whole Alnitak region with Horsehead is it's a pretty cool thing, and it fits pretty well in my sensor, so it's a fun thing to do. Fun thing for me to do. Yeah, as Pimal said, when you look at Orion, you can all easily see the belt there, and then there's 3 stars hanging down that make up the sword. And the reality is those 3 stars aren't actually stars. They are clusters of stars and bright nebulae that are star-forming regions. We'll go look at some of that next. We'll take a couple more minutes on this. We'll let this smooth out a little bit. The more subs you take, the smoother it looks. Come on, you. Yes, Tatiana, you can easily see Orion in the southern sky right now. You guys are also in California, so if you look pretty much straight south and up about 45 degrees, so about halfway up to the very top of the sky, you should be able to see Orion pretty easily if you've got a clear skies where you're at. It's a very large, easy to identify constellation. Okay, yes, you should go out and check it out. It's there's nothing under the stars, although my live streams come close. But actually seeing them with the naked eye, and if you have a pair of binoculars, bring binoculars with you, and you'll be really surprised by what you can see with binoculars. Just simple, low-powered binoculars. You can see a lot of stuff. You'll be amazed at how many stars you can see in the band of the Milky Way just by adding a low-powered pair of binoculars to your eyes. Now, remember I was talking earlier about this meridian line, this magic line here, which I need to pay attention to, because we are quickly approaching that line and my mount will not be able to. So what I may do is I may actually wait a couple of minutes here. What I could do is we could do a little bit on Rosette while we wait for this to cross the meridian, and then I'll go over and we'll do M42, we'll do the Orion Nebula. But we can go over to the Rosette here in a minute. But this is a really pretty area. The downside is that there's a lot of satellites in the southern sky, so I get a lot of trash in here. But the Rosette is nice. It's too big for my whole sensor, but we'll go spend a few minutes on that and then come back to do the big spectacular Orion Nebula, which was not on the plans for tonight necessarily, but given that we have so many astronomy students here, I think it's very instructive to see these areas, because there's many different things in here that are very interesting. This is the whole Orion area of the sky is a very active area for star formation, those kinds of things. So, the Flame Nebula and the famous Horsehead. Now you know where they are. So let's go look at Rosette for a few minutes. Wait for Orion to cross the meridian, and then wait for Orion to cross the meridian, and then we'll go over and do that. Let's plate solve it to make sure we're centered up correctly. We were not, so I'm glad I did that. In fact, I need to synchronize. Stellarium. Okay, now let's take a look for a few minutes at the Rosette Nebula. And this is another emission nebula that does really well with narrowband filters, but we're not doing narrowband filters tonight. We don't have hardly any moon in the sky here for at least the next 45 minutes or so. So we can just look at things without any filtration at all. But this is a hydrogen beta region. That's an emission nebula located near one end of a giant molecular cloud in Monoceros region of the Milky Way. So this is kind of right next to Orion. You got Orion there with his arm up, and the Rosette is right there in this cluster. It's going right through the band of the Milky Way. You can see this light area here. So it's right in the heart of the Milky Way. And there it is. There's our first picture of it. It's a pretty one. And as we get more subs, it'll... oh, actually I should make sure I check that. Yeah, that looks pretty good. As we get more subs, it'll come in. It'll come in a bit better. But this, the open cluster NGC 244 is closely associated with the nebulosity, the stars of the cluster having been formed from the nebula's matter. So this cluster of stars in the middle, which is also called NGC 2244. I think actually the cluster is a Caldwell number. Yeah, it's Caldwell 50, or NGC 2244. It's in a few different catalogs. But this is a star-forming region like almost everywhere in the Orion area. And so some of these stars were formed from this nebula. So it's another stellar nursery. Just like the Orion Nebula we're going to see here in a little bit. The nebula has been noted to be having a shape reminiscent of a human skull and is sometimes referred to as the Skull Nebula. But it's not. I prefer to call it the Rosette because there is actually another skull nebula, NGC 246, which actually looks a lot more like a skull. The cluster and nebula lie at a distance of 5,000 light years from Earth, and it's approximately 130 light years in diameter. So the light that we are seeing from this left this area 5,000 years ago, and where it's just getting here now. All the astronomical objects are so far away that it takes light that long to get here. And it's about 130 light years in diameter. So, very, very large. The radiation from the young stars excites the atoms in the nebula, causing them to emit radiation themselves, producing the emission nebula that we see, which is why it's called emission nebula. As opposed to the Seagull nebula we were looking at earlier, which is a reflection nebula, which simply reflects the starlight of the stars in and around it. These are actually ionized and actually radiate their own light, emission nebulas. The mass of the nebula is estimated to be around 10,000 solar masses. So, in other words, it can still create quite a lot of stars yet. A survey with the Chandra X-ray Observatory revealed the presence of numerous newborn stars inside optical Rosette Nebula. That's oddly worded. And studded with a dense molecular cloud. Altogether, approximately 2,500 young stars lie in this star-forming complex, including the massive O-type stars, which are primarily responsible for blowing the ionized bubble. Most of the ongoing star-forming activity is occurring in the dense molecular cloud to the southeast of the bubble. So, yet another star-forming region with some of its youngest babies still visible in there before they move out of the house on their own. Yep, they have Stellarium for mobile, they have Stellarium for PC, they have Stellarium for Mac, they have Stellarium for Linux. So no matter what your favorite device is, they have it. And it's also an open source project, so it's free, and it's educational software, so it's a really good project. And they're of course always looking for people to come offer to help. And so if you have any coding interest and love astronomy, they always love the help to keep improving it. Looked like Orion's pretty much moved across. So we'll take a few more minutes on the Rosette, and then we'll move on. And you can see here, just as with the Flame Nebula, there's dark nebula matter that's in here, not dark matter, but dark nebulae that's in here that's causing these. So it's just dark gases that are between us and the Rosette that cause this interesting sculpture or these interesting features here. And you can see there is a bit of a difference in color as well. There's some reds, and there's more whitishness. And in general, which are the red, like the Horsehead Nebula that we just saw, that tends to be hydrogen. And the lighter tends to be oxygen. And so this has a mixture of things in it. Unlike the Horsehead, which was just very red and is probably mostly hydrogen. The Flame, which was more of a tan, was probably more of a mix. This is another large object, and as such, binoculars might be able to pick this up if you're in a really dark sky site. You'd be able to see, of course, the star cluster pretty well, probably from anywhere. Because these stars are nice and bright young stars. The nebulosity would be harder to see without either dark skies or longer exposure camera stuff like we're doing now with my 60-second exposures. Of course, out here I have both. I have dark skies and the camera, but you might be able to see something from a dark sky site with binoculars. It's just such a nice object. My field of view, so a fairly good size object. Let's see how my guiding is doing here. Doing pretty well. A little kerfuffle there, as happens. There's the 10 minutes of subs right there. So the Rosette Nebula, pretty cool looking nebula. Nice and bright and shiny. Okay, so now we're going to have to, remember what I told you before, I'm going to have to do what's called a meridian flip. So we're going to have to actually go, the scope is actually going to have to go all the way around and come back at this from the other side to get to get where we're going next, which is over here. Lower sword, let's go up here. Upper sword. Well, whatever. Upper sword is fine. Okay, let's let's have Stellarium crash. Boy, didn't like that. Okay, I guess we're gonna restart Stellarium. Come on, Stellarium. Okay, let's make sure you are where you are supposed to be. Doesn't look it, so let's make sure we get the scope connected. There you are. Okay. Now let's go over to here. Alright, now we're going to do the big old meridian flip. Put it all the way over on the other side. Okay, so that was a long slew, so we will need to there we go. Now I think what this is going to focus in on, if I'm correct, is going to focus in on, yeah. So I think this will get me. We'll take some quick shots of this. But this is probably going to give the upper sword. Okay, yeah, so what we're going to do is we're probably going to be getting the upper sword and what we call Running Man, which is the top part. So essentially the top star of the sword of Orion. This is actually the top star. When we see the top star, it's actually this area in here. We're kind of getting this whole thing here. Kind of the top two. Stars. And this here is called, this here on the left is, we call it Running Man. Because it kind of looks, they've got one leg there and one leg there, and somebody looks like a guy running, a person running. So, but you can see this is, these are bright blue young stars that are in an area of intense nebulosity. it's very blue, which likely means this is mostly a reflection nebula. They're just reflecting the light of the young stars that this gaseousness probably just formed. And you see 1981. Let's see what Wikipedia has to say. NGC 1981. Is an open cluster in Orion. It was discovered by John Herschel on 4 January 1827. So almost 200 years ago. Its apparent magnitude is 4.2. Size is blah blah blah. Lies to the north of the Orion Nebula, separated from it by the Sharpless 279 region containing NUC. Blah blah blah. Some say it looks like an alligator or crocodile with its eastern stars as the snout, its western star as its tail, and the two groups of 3 stars in the middle of it as its 2 sets of legs. So, mouth, eyes. I guess that's an alligator's head. Of course, you can also see a body here, and maybe a head here, and a tail over here. It's like looking at clouds and seeing what you think you can see. Everybody's going to see something different, and you can get as creative as you want. But this whole area, the whole Orion, well, molecular complex as it's known, the entire Orion area, this whole area of Orion is just very rich with nebulosity because there's a lot of gases here that are in, there's a lot of star-forming regions, and so there's a lot of very young stars being born here, and it's, you know, it's only 1,000 or 2 light years away, so it's relatively close to us, and there's just a lot of stellar activity here. In a few minutes we're going to go to the Orion Nebula, and that is just a very large area of, that's another stellar nursery. But there are many around this whole Orion area. Actually, I should probably, something I didn't do at the very beginning. Some people like to see the setup that I'm using, so while that's collecting, where is, there it is. Well, that's collecting more data, I'll actually show you what my setup looks like. And so this is kind of it. It's a 6-inch imaging Newtonian, just a simple reflector telescope. But it's an imaging Newtonian, meaning its focal ratio is faster, which is better for taking images. It collects light faster, basically. And here's the focuser, and the camera is stuck in there. And the mount that drives the scope around the sky, Stellarium tells it where to go, and it goes. And then my homemade tripod that I made out of 2x4s and 1-inch cabinet-grade plywood. It was either this or pay $300 for the fancy one that came with this, and I'd rather just build it myself, so I built that. So this is what I'm using. This is an equatorial mount, which this axis right here points right at the North Celestial Pole, Polaris, or just slightly off Polaris, the North Star, and you precisely align it, and then it tracks the sky very accurately when you're taking images. So even when you're taking long 60-second exposures like this, you don't get star trails. Everything stays sharp because it tracks the movement of the sky, or more technically, the Earth's rotation. The sky is actually stationary, but it tracks the sky as it moves across. Us. So. Yep, so I spared no expense on that one. You know, when you got scrap wood lying around that's not doing anything else anyway, might as well do something with it. So I can basically stand on the thing and dance around on it. It's very strong, so it works more than well enough for my purposes. And the whole thing weighs, the tripod only weighs about 10 pounds, and this weighs about 11 pounds, and this only weighs about maybe 14 or 15. So it's not a very big or heavy setup. It works well for my purposes. So all right, we'll finish this sub-exposure, and then we'll go over to the main nebula. So this is basically the top star of Orion's belt. It's kind of this part here is kind of the top star, and then the middle star is the Orion Nebula. The bottom star is that below part there. And we'll let this finish dithering. There we go. Okay, next target. Very good. And we're already there. Let's make sure we're going to be... Yeah, that'll be just about right. We'll see that this is still the very top part, the very bottom part of what we were already looking at. And so, I actually want to bring this down a little bit. So I'm going to... Let's do a quick plate solve so I can move this actually down a little bit more, so we can get more of the... So what I can do is I can actually, with this, I can actually select a spot and say, I want this star to be the very center of the... What? No. I want this star to be in the center. Not this. I want this one to be in the center, so it'll move the whole thing up and to the right. So we'll say, yes, please move. And it will move the whole thing up, because there's a lot of extended nebulosity out here that we will want to look at. Okay, so let's start imaging. Now this is a very bright object. Obviously when you look outside at Orion, you can see the sword hanging down from his belt, and you see there are 3 apparent stars there, and the middle one is the Orion Nebula, what we're about to look at here. So it's a very bright object. You can see it naked eye from most places. Probably not if you're... The sword is probably hard to see if you're in city lights and whatnot, but if you're even in a remotely dark area, it's fairly easy to see, and so it's a really bright thing. Not quite as bright as a star, but it's big, and so it has a lot of light. And so the challenge with you when using a very sensitive camera is trying to see all of it, because as you'll see in a minute, the central part, which is the stellar nursery, is very bright because there's lots of hot young stars forming in there, but there's a lot of extended nebulosity that comes out from it that's, you know, that's very faint. So trying to get everything into one is trying to see the bright stuff without it being blown out like this, and see the outer stuff without it being too dim, is a bit of a challenge. So we will do our best here. I want to back the stretch off quite a bit. Normally I don't actually even do this at 60 seconds because it blows the whole core out. But you can see that there's a lot of extended nebulosity in here. So the stellar nursery is in here, and there's a lot of bright stars in here. In fact, there's a famous asterism in here called the trapezium that some people test the resolving power of their telescopes in to see how many stars you can actually individually see. But when you're taking long exposure photography, it's it's a challenge to try and see anything in there. So, but you can see there's a lot of extended nebulosity here. This is a very large object, and this is why it's the central star, because this is just a big, bright object. But this is a stellar nursery. Probably one of the most famous ones, the Orion Nebula. But trying to adjust the image such that you can see that you can see all the faint nebulosity, but not have the core be totally blown out is it's quite a challenge. See, so I can stretch it out quite a bit so that we can see the extended nebulosity, but then the core is just blinding. But you can see it's a large object. And then we take the stretch all the way out, so you can hardly see anything, and then only then do you start being able to resolve that there are actually stars in here. But then you can't see any of the faint stuff. So it's an interesting photographic challenge. You just usually kind of pick a happy medium and go with it. Nebulosity of gaseousness, where there are stars being formed. This is also known as Messier 42, or the Orion Nebula. And you're as you've been told here tonight, you'll be learning more about the Messier list later on. But this is the 42nd object that Charles Messier put on his list. And to give you a sneak preview, he was a comet hunter basically, and when he looked into the night sky, he kept seeing these same objects, and he would study them and then realize that they weren't comets, and so he started building a catalog of things that weren't comets, so he wasn't constantly, looking at the wrong things. He was, always researching new things and could ignore things that he had already observed. And so he started making this catalog of things that he did not want to observe, and ended up making and so what he ended up doing was making a list, making a list of some of the brightest and most spectacular objects in the sky, And so as a result, it's one of the most popular lists that amateur astronomers look at, because it is just a collection of wonderful objects. But he was building a list of he was building a list of things to not look at, and ironically enough made one of the most spectacular lists to look at that there is. Okay, the Orion Nebula, also known as Messier 42, so this was the 42nd object on Charles Messier's list, or NGC 1976, which NGC means New General Catalog, so it's one of the catalogs of astronomical objects. It's a diffuse nebula situated in the Milky Way, being south of Orion's belt in the constellation of Orion. It's one of the brightest nebulae and is visible to the naked eye in the night sky with apparent magnitude of 4. It's approximately 1,350 light years away, which means the light we're getting from it now left there about 1,350 years ago. And is the closest region of massive star formation to Earth. The M42 nebula is estimated to be 24 light years across, so its apparent size from Earth is approximately 1 degree, which is about right, because that's what my sensor size is. It has a mass of about 2,000 solar masses. Older texts frequently refer to the Orion Nebula as the Great Nebula in Orion, or the Great Orion Nebula. The Orion Nebula is one of the most scrutinized and photographed objects in the night sky and is among the most intensely studied celestial features. The nebula has revealed much about the process of how stars and planetary systems are formed, from collapsing clouds of gas and dust. Astronomers have directly observed protoplanetary disks and brown dwarfs within the nebula, intense and turbulent motions of the gas, and the photoionizing effects of massive nearby stars in the nebulae. It is visible with the naked eye even from areas affected by some light pollution. It's seen as the middle quote-unquote star of Orion's belt, of the sword, which are the 3 stars located south of the belt. The star appears fuzzy to sharp-eyed observers, and the nebulosity is obvious through binoculars or a small telescope. It contains a very young open cluster known as the trapezium cluster, due to the asterism of its primary 4 stars within a diameter of 1.5 light years. 2 of these can be resolved into their component binary systems on nights with good seeing, giving a total of 6 stars. So that's where I was getting at with how some astronomers test the resolving power of their telescopes by seeing how many of the stars they can actually resolve in this core. It's nicknamed the Turkey. That one I hadn't heard of, but I guess given this head here and the big plumes, I guess that sort of makes sense. But yeah, this is one of the most spectacular objects in the night sky. Really is something. And before we moved it up a little bit so that I could get all of this nebulosity, which I call Running Man, but some people call Running Man. But this is the middle star. So kind of looks like 3 stars, but 1, 2, 3. And then the bottom thing here, the lower sword, the lost jewel of Orion, which is a lot like Running Man, but just a bit less nebulosity. But it's just a bunch of hot young stars that form the very bottom star of the sword, and they're just surrounded by some nebulosity. But the whole Orion area is just really, it's a great place to observe. Take your binoculars and or a small telescope and head for a as dark a spot as you can find and cruise around in it for a little bit. Yeah, there we are. The Orion Nebula. Okay, well that was a fun detour. But we should probably see... Let's see how that guiding went. Yeah, doing good at dropping. Okay, let's see where we are with our list now. We did the Seagull. Oh, the Witch Head. They actually did have us do the Witch Head. And the Witch Head actually is right close to where we are. That's this right here. So right next to Orion is the Witch Head Nebula. It's a very faint, subtle area of nebulosity. Once again, in the Orion molecular complex, where there's just a lot of dust and gases that are doing a lot of star formation and other things. But this is the Witch Head here, and it's a pretty wispy little area. Nothing nearly spectacular as what we're seeing here. Of course, this is kind of the biggest and brightest thing we'll see all night. But it's still a nice thing. So we can go do a few minutes on the Witch Head. It'll probably be about right. Where's the... Come on. There we are. Yeah, something like that. Maybe even this one. Yeah, probably something like that. Nebula family. But right close by. Just going to be a lot fainter and more subtle. And we won't even bother doing a plate solve on this one because that was a pretty short slew, so we should be pretty well dead on. And then what I think we'll do is we'll go look at a few Planetary. Yep, the Witch Head. She's definitely witchy looking. Well, we'll get to see a small part of her. Again, the box is my field of view. And when I have my my wide field rig on, I have about 3 times this size. And that gets me a lot more. But this will at least give us a piece of the nebulosity that's in this region. And then I think we'll go look at some planetary nebulae. Planetary nebulae are very interesting things that are not actually nebulae at all, but they're called nebulae. So I don't know if you guys will be talking about planetary nebulae this in this semester or not, but they're a very interesting phenomena, and they're basically something that will happen in our solar system too, when our sun is basically part of the aging process of stars like our sun. And now you can see the clouds here. You can see it just starting. So I got a little bit of the edge and some of the middle. So that's about perfect. You'll be able to see the contrast. We'll get some more data in here. And a few more subs that'll smooth out and get a little bit brighter. Boy, got quite a beautiful night here, though. Don't know how things are up in the Monterey Bay area, but it's a beautiful night here. Warm, calm, clear. Kind of doesn't get much better than this. Oh, good. Yeah, ring is one of the nicest ones. It's a small one, but it's a very bright one, which unfortunately is only up in the summertime. So we can't actually look at it tonight, not live at least. But yeah, the Ring Nebula is a good one. While this is building some color, I think I will go refill my water glass. I'll be back in a minute. Good night, Pamal. Thanks for stopping by. It's good to see you finally being part of one of these. So that's great. And hello to your students. I'm glad you guys were all here. It was fun doing this for you. So you can see the nebulosity really starting to pop out there a bit. Well, and I appreciate your attendance. It's nice having folks who are interested. Thank you, David. Thanks for being here. Stretch it a little bit more. All right, well, I think that's pretty good. Let's see what we're going to go to next. Let's try some planetaries. The Eskimo Nebula, the Medusa, Rhinoceros, you see 2022, Gemini, that means Castor and Pollux, which are going to be it's going to be, well, those actually still on that side of they're still on the east side. So we'll try NGC 2022. Okay, NGC 2022. That close, okay. Cool. Alright, so we'll try this, which is right in the top part of Orion. We'll try that now. Okay, goodbye, top of Witch's Head. And we'll go to this little planetary. Now these guys, for the most part, tend to be very, very small. Yeah, there it is right there. You can see it even in this short exposure. There's something there that's more fuzzy than a regular star. So we'll take a look at this. That's not what I was trying to do. Come on. Trying to do this, not that. Okay. Well, we're going to need to back this stretch off a bunch. Pick this up and bring it over. You can see this one looks just a bit different. These tend to have, it's a bit sharper, and it's also bluish in color, much more so than any of these other ones, any of these other stars. So it definitely looks different, and this is how actually they got misnamed as nebulae, planetary nebulae. When they were first discovered, the astronomers knew that they weren't stars because they looked different. I mean, this just looks different. It looks more like a planet in our solar system than it does a star. But they couldn't figure out for sure but they didn't think they were planets. So they got misnamed planetary nebulae. And what they really are is dying stars. They're dying main sequence stars, just like our sun. When our sun gets old, in about 4.5 billion years from now, it will begin to expand and will turn into a red giant, as Pamal said, and you guys will be learning about later on. It turns into a red giant because it stops burning one fuel. It runs out of its primary fuel of hydrogen, and then it starts burning helium, which makes it go through changes, and in any event it expands, it swells to a red giant, and in fact the diameter of that star will probably come close to, if not consume, the orbit of the Earth, is how big it will swell as the red giant. And then what it does is it blows off its outer core. Hey Greg, good to see you. It blows off its outer core, blows off its outer layers, which expand outward through the star's solar system and continue outwards. But the core of the star continues to burn, and it becomes a white dwarf. And it continues to burn, and so, but it's just cooler. But it's enough to illuminate the expanding gases that it blew off before. And so it becomes this huge ball of glowing ionized gas, and it's called a planetary nebula, both of which are misnomers because they're actually a star, but it it ignites all of that material that it blew off as it dies, and so that's what a planetary nebula is. And our own sun will go through this, and like I said, about 4.5 billion years, it'll go through this process itself. So unfortunately they're so small that there's really not much to see. There are a few that are bigger and are easier to see, but the Ring Nebula being the most famous, even it is not very big at all, but it's only visible in the summertime, and fall, so we can't really see it right now. But it actually is a full-on ring, so. But you can see that it definitely looks different from a star. All the stars that are around here look very different from this planetary nebula. It's got a nice greenish blue ring around the edge of it, and it just clearly looks different from stars. But it's very, very tiny, so we're probably not even going to spend any more time on it than that. We'll try the Eskimo. Well, let's see, that's on the other side. Gemini, Gemini, Gemini. Well, these are all Gemini, so we'll probably just do a meridian flip and go over and get it. But that's a very small planetary nebula. send to next target. NGC 2392. Yeah. It's going to require a meridian flip because it's all the way on the other side. C 2149. Yeah, so this is going to be in Auriga there, so this is going to be in the northern sky. Okay, send the telescope there. Yeah, that's in a pretty good position. Okay. Plate solved to make sure we've got it centered. Boy, 3/4 of a degree. Alright, well there it is again, looking very star-like. But oh, you're doing monkey head. Cool. Yeah, I was just doing the jellyfish last night. I did jellyfish and spaghetti in narrowband last night. And but I was only doing 3-minute subs, so I wasn't able to get a whole lot out of them. Jellyfish I got fine, but spaghetti is so faint. So tonight, right after I wrap up here, I'm going to actually leave my setup outside for a while and do a 5-minute darks library for my camera that I was using. On my wide field rig I don't have a pro camera, so it doesn't have a cooler, so I'll leave it outside and run a 5-minute darks library for it so I can try spaghetti again, this time with 5-minute subs. But yeah, monkey head. Actually, we did monkey head last night. Yeah, 10 minutes is the way to go. Oh, I gotta plug a laptop in. Hold on a sec. Okay. Yeah, 10-minute subs. That's the stuff. So again, here we've got right middle. We've got something that looks. This one actually has some interesting filaments coming out of it, though. Huh. So some of these are they're just so small they're hard to distinguish from stars. Yeah, it's pretty hard to. They're just so small. I think we're going to spend more than a couple of subs on this because it's too small to really even be able to. With my setup, it's too small. Good night, Bertha. Thank you for coming. Hope you got to see some. Hope you learned some stuff tonight. Among them being that astronomy is fun. We really enjoy doing it. Yeah, I don't think I want to spend a lot of time on this. There's not a lot to see there. The Eskimo and Medusa means I'm going to have to do a meridian flip, which I can do. $23.92 is going to be over here. Boy, it's getting close too. Yeah, but I think I should just go do it. Because there's just not a lot to see here. But it's so small, there's not a lot to see. Uh-oh. Looks like SharpCap may have just crashed. Yep, looks like SharpCap may have crashed. Oh, no, it looks like it recovered. Okay, looks like it may have recovered. Let's try it again, just to make sure it completed everything. Okay. No, it didn't. Is that okay? Good. So let's do a meridian flip. Head back over to the other side again. Do a couple of quick planetaries. I think the Eskimo is a bigger one, so hopefully we'll be able to see a little bit more out of that one. It's going to go all the way to the top. Okay, good. Let's do a quick plate solve. Make sure we've got it centered. 4.5 degrees. That's weird. You know, there it is, right there. Okay. See how our guiding is doing here. Yeah, I think I probably just invoked the sequence while it was transitioning to dithering or something. Alright, let's see if the Eskimo will give us a little bit more something to see for a planetary. And we could do a couple of galaxies too, even though with the color camera they're not going to come out great, but yeah, see again, it's clearly not a star, but what is it? So what you've been using the 2600 color, right? That's what you got, the 2600. Now you're back to the mono. Yeah, you get both 2600s for both, yeah. Nice cameras. Basically the big brother to what I'm using tonight, the 533. Which is a great color camera. I've really liked this new sensor technology. Although I've been spending a lot of time with a 183 color lately. I've been broadcasting a lot on Night Skies Network. And been using my wife's old Canon L series lens. She has a 2.8 f2.8 80 to 200 millimeter Canon L series lens that I got a ZWO adapter for, and put a 183 color on the back of it and a little guide scope and guide camera. And I've been doing some wide field narrow band stuff with it lately, which has been a lot of fun. So, you know, doing things where the Rosette only fills, you know, a quarter of the screen or a third of the screen, and doing, you know, all of the jellyfish and surrounding area. And I can't get all of the Spaghetti Nebula in, but I get most of it. I just need to get longer subs. But yeah, it's been a lot of fun doing that. Yeah. No, it's the 80 to 200. It's about 30 years old. My wife bought it back when we lived in Boulder, probably in the early 90s. She bought it. So it's the old one, not the, I think the 70 to 200 is a newer one. This one's back from the late 80s, early 90s. Good chunk of glass, but about 30 years old. So again, not much we're going to see from this planetary except a bluish-green ball that's clearly not a star, but still a bright object. Well, it's not a regular star, I should say, because it is obviously a star. But that's about all we're going to see for planetaries. What else has he got in here? So planetaries, yeah, we've done those. The Medusa. The Medusa Nebula is also here. The Medusa Nebula. Well, actually, this is a bit more. This is a bit bigger. So let's go do the Medusa. That looks like something we can actually spend a little time doing some capturing on. Oh, what did I don't think I resynced after that, did I? Oh, Lowers Nebula? Yeah, well, actually we did that earlier. I did that earlier tonight. Okay, what am I doing? This. Let's start. No, not scripting. Sequencing. Start imaging. Yeah, I did Lowers actually earlier tonight. And in fact, I added it to my emission nebula list, which I didn't have it on my emission nebula list. I want to get that one with my narrowband setup. It did a half decent job with the 533 broadband, but I'd like to get I thought it was a mission. Let's look. Oh. Where was it? Sharpless 2261 lowers. Well, SH2261. Yeah, SH2261. Yeah, hydrogen beta. So, looks to me like it will respond very nicely to narrowband. We'll see. We shall see. I will definitely give it a try. Okay, so there we are. The Medusa Nebula. Let's actually do a color balance on this because it looks like it's a little bit off. Alright, bring you there. Bring you up here. And we'll let you build for a little bit here. Yeah, me neither. I didn't know about it till tonight. I've never shot it either. I I didn't know about it till tonight, so just added it to my list and go give it a shot. We also just did a nice rosette. Speaking of things you've liked to do, just did a rosette here a little bit ago. We did rosette, not Almatac and M42, etc. Rosette's nice in this sensor. It just fits into my field of view perfectly, being just over a degree. Yeah, monkey head's good. I've done monkey head. I've done it broadband and I did it last night narrowband. It's a fun one. Galaxies. Yeah, Medusa, relatively large and faint for a planetary. Cool. Are you going to go to Furnace Creek at all this weekend for the Dark Sky Festival? You don't usually go to those kind of things, but figured I'd ask anyway. Although the weather is not exactly looking ideal. It's looking like we're going to have clouds on Saturday night and then wind on Sunday night. But yeah, this is actually pretty good, Medusa. I would like to take a little time on this. It's faint, but we should be able to pull in some color. Oh wow, you have to work Friday and Saturday nights now? That's a bummer. That'll put a crimp on your social life. Yeah, it's not looking ideal. So, I'm sure I'll probably go for Saturday night. You know, clouds, well, whatever. You can still hang out with people and chat and, shoot some soccer holes here and there, but, so that, that seems okay, but wind, nah. I would rather keep the dust and dirt out of my sensors and optics. So, I will probably not attend on Sunday, but, unless the forecast significantly changes, of course. Yeah, social life. Yeah. So I'll probably go for Saturday night, but Sunday night, yeah. I've still got double digits watching here. Well, see how we're doing. Probably stretch this a little bit more. Bring this in a little more. Stretch this out a little more. See it a little better. definitely a nice little object. Medusa Nebula. And that's a planetary, huh? Well, not all planetaries are circular in shape. This one seems to be blown into more of a scoop shape or something. But somewhere in the middle of this is a star, probably a faint star. Maybe that one. Maybe that one, who knows? That is lighting it all up, that blew all of this material out there. So, kind of a nice object, though. Faint but pretty. There's a lot more fainter nebulosity you could probably bring out with longer subs. Oh, I'm sure I could. But right now, well, actually, you notice on this last sub, the background sky actually brightened. That's because we've hit quitting time. The moon is basically rising, or getting close to. I think it's actually rising in about 10 minutes. So the sky is starting to actually lighten. So that means my night is done. I figured I would be done by 9:30, and this is about perfect. So I'll just finish with this object and call it good. Yeah, I never used to want to do long subs. I mean, I never wanted to do more than 60 seconds at one point. I never wanted to do guiding. Never wanted to do any of that stuff. But, then I got a filter, and it's like, oh, well, I can't see anything with this thing at 60 seconds. So then I started guiding, and after a learning curve and some growing pains with that, figured out guiding is pretty easy and good to do. Started guiding, and then started doing 3-minute subs, and that's great. And now I'm even toying. I mean, I've even done 5-minute subs a few times. I don't like doing it when I'm broadcasting on YouTube. Seems a little bit long to wait for a sub when I'm doing, for the YouTube crowd. But when I'm on NSN, absolutely, 3 and 5-minute subs are just fine. And so I've started doing longer and longer subs, and guiding is working well. And now that I have the AM5 instead of the AVX, my guiding is a lot better. That's my newest toy. I guess I could show you that. See, I got an AM5 and put it on top of my no expense spared homemade tripod, which is rugged as heck. And so that's what I'm now using instead of the AVX, and it's a lot stronger and weighs a fraction of the weight. So yeah, it does good. And I'm usually guiding at 0.6, 0.7 arc seconds, sometimes less, sometimes more. These strain wave mounts are interesting creatures. Yeah, but you can see this is starting to wash out. The first several subs, the background got dimmer, and it got darker and darker, and now with every subsequent sub it's getting brighter and brighter, so I'm basically losing my contrast. Yeah, they're great, especially for portability. They only weigh 11 pounds, and you can run them up to, I think it's 25 pounds with no counterweight and 44 pounds with counterweight. And really the only reason you need the counterweight is not because the strain wave needs the strength, but because to keep your tripod from tipping over. So they're pretty cool. I really like it. liking it a lot. But they're great for portability. But yeah, I think I am actually going to call it a night here, guys. My skies are disappearing. It's getting brighter and brighter, and so we're going to basically we're going to lose the stars here. We're going to lose the sky. So, well, we got a few good subs earlier on in this, but now it's just getting too bright, and it's just starting to wash out. So, I am going to call it a night. Thank you, everyone, for being here. Thanks, Greg, for chatting at me, and I will see you guys now. Like I said, like I said earlier, I don't know that I'm going to be doing a lot more broadcasting on YouTube. I like doing Night Skies Network. If you want to go check that out, nightskiesnetwork.com. I'm a broadcaster over there, and it's a lot better than YouTube for a lot of reasons. The only downside is there's no recording. So, you know, my parents and friends on the East Coast can't see it the next day on the recording, but. So I'm going to be doing most of my things over there, but I may still come over here now and again and do a broadcast. But anyway, thanks everybody, and good night, and I will see you next time.